Hello, everyone, and welcome to another Rust stream. My name is Luciano, and today I'm joined by Roberto.
Hello.
And if you are new to this channel, what we do here, we always try to find new excuses to learn Rust. And lately, we have been working towards some coding challenges from this website called CodeCrafters. I'm going to drop the link in the chat. And it's a referral link because this is a service that has a paid version. And if you use this link, you're going to get, I think, the 40% discount or something like that. But yeah, the idea of this website is something like if you have done any coding challenge, like I don't know, Hacker Rank or these ones, it's kind of similar, but rather than doing isolated coding challenges, you are actually learning to build somewhat of a real product, like a Redis clone, a BitTorrent clone, SQLite clone. There are a few different challenges, and we are working towards a challenge that is about re-implementing the BitTorrent protocol. I think we're going to be implementing more of a client, so not the entire protocol, but still, we should be able to download a file if we do everything correctly at the end of this challenge. Hopefully, I didn't forget anything. Roberto, do you want to add anything there?
No, yeah, we are doing this BitTorrent stuff. We did a bunch of steps already. Let's see where we go today.
Yes. So, should I put your screen on and we go through maybe all the steps that we already covered really quickly,
Yeah,
and then what's the next task?
sure.
Okay,
So,
so your screen should be on. Hopefully, it's readable for people. If it's not, please drop a comment in the chat.
so we started, basically the real work started here, before we were set up steps. We started parsing something that is called B encode, that is B encode, sorry, pronounced B encode. That is how BitTorrent encodes data, string, integers, array, and dictionaries. So we started parsing that in string, integers, list, dictionaries. Then we had to start parsing the BitTorrent file, the BitTorrent binary file itself that contains a structure that we mapped with a Rust struct. Uh, we had to compute the SHA-1 of the dictionary that was being encoded inside the. We had to basically get the info out of this sample torrent file, and we had to create the SHA-1 of this file. We had to take all the SHA-1 of the pieces that are going to compose the BitTorrent file that not BitTorrent file, the file that the BitTorrent file points to. It is made of 3 pieces of 32K each one, and those are the SHA-1, the hashes of the 3 different pieces. Then again, we had to make a network call to get to the tracker that is specified here inside this torrent file. There is a URL. This URL, you have to call it. When you call it, you have basically back a list of the peers that have this file.
Mhm.
You have to call with a specific parameter, and we had some troubles encoding the info hash because it needs to be sent as a binary, but the request is not super happy putting binaries in the query parameters, so we had to do some dirty tricks there. And now that we have the peer that we have to contact, the next step is to implement a command inside our client called handshake, that given a file and a peer and port is going to give out something. Basically, it needs to connect to the remote
Mhm.
server and do some kind of handshake there.
Which is
So,
probably the beginning of starting to talk with a peer and request files and
mhm,
downloads files.
yeah, here there is a explained what we have to do. Basically, we have to send after we send the handshake to our peer, we should receive an handshake back in the same format. The format is length of the protocol string 18, 19 in 1 byte, so it will be a byte with 19 in it. This
Mhm.
string, literally verbatim this string, 8 byte at 0, the SHA-1 of the info hash that we computed before, but again, the binary version of it, not the hex-encoded version of it, and our peer ID, 20 bytes. Last time we are coded it, if you remember, we are coded our peer ID with just 20 bytes, not
Mhm.
very random, but is not important. I mean, is something that our client is able to choose. Normally, is random. In here, we just coded it. Why not? So yes, we have to open this. What is this? A TCP connection is stated up here to this peer and port. Send these 19 bytes. No, sorry, they are more than 19. They are 19 plus 8 plus 20 plus 20. Send those bunch of bytes and getting back the same amount of bytes. In theory, being not a lot of bytes, we should not have the problem with buffer sizes, pagination of the buffers in the network protocol. These are problems that maybe we will have later when we start
Mhm.
downloading the file for real. So, what can we use to do this kind of low level connection, TCP connection in Rust? I don't think request is the right crate to use, but
No, I think we can use Tokyo. The async runtime also should have some TCP networking
we're already
utility.
using Tokyo for our main, so we can use it for our these utils. Before doing that, if you remember, I said that we have already some commands, the code
Mhm.
info, the code info and peers. Okay, we should add a fourth command. What do you want to do, Luciano? Do you want to refactor this a little bit because now it's getting a little bit ugly, if you ask me? Do
Yeah,
you want to refactor a little bit the body, or do you want to go on in the network protocol and then we refactor it at the end of the stream?
we could quickly try to implement clap. I think I should have, excuse me, an example that we can follow.
Okay, so our cargo toml, then we have to go to do. Oh, clap is already here, by the way.
All right, and it already has the feature we want, that derive feature. So
Right.
that's
Okay,
perfect.
so perfect. I never used it, so
Okay,
guide me through this.
I'll try to tell you how it works.
Yeah, what should we use?
So let's see. So I think we need to create a struct called args with uppercase A. Just create the struct, then we will import whatever needed.
Okay, public struct, private, public,
I don't think it needs to be public.
args or arg.
We can decide, but let's call it args. Just I think feels more
Ah, because it's
conventional.
not okay, it's not mandatory by okay.
Yeah, and this one needs to derive parser, which comes from clap. So as you do, hopefully it's gonna give you an autocomplete. Yeah, that one. And you can also
Okay.
add debug because maybe it's needed. Okay, so at this point, this one takes a subcommand. So the idea is that this is not just a CLI with like one functionality. It's a CLI
Yeah,
where you call it and you pass the subcommand, and then the subcommand can have different arguments. So,
different argument, yes.
so the way you do this with clap is that here we have to create a property called command of type command with uppercase, which is also a clap type.
Maybe with only one O that you say is another clap.
Exactly. And this one
Okay,
needs also a
sorry. I'm fixing this because it's annoying.
yes, you can do that. I'm surprised it didn't do it automatically, but whatever.
Ah, my editor is it's different.
So here you need to add another macro at the field level, another like the derive. So hashtag square brackets, and it's called command lowercase.
Command lowercase.
And then
Okay.
parenthesis subcommand. Sorry, this is a bit of a boilerplate. Okay, hopefully that should work. And now, of course, that command is something we need. Actually, sorry, command doesn't need to be imported. It's something we need to create. So remove your import. So it's basically our enum of all the
of the
supported
possible
commands.
command. Okay.
So you can do an enum, call it
Yeah.
command, and then what do we have? We have the code.
Okay, the commands that we want. Let me take a look. We Where are they? The code
The code
info
info.
here's, and now we have to add a new one. Do you want to do the refactor? Then we add the new one.
Yes, let's do the refactor first. Now I think that Rust wants this to be uppercase, and there is a way to do the auto rename.
Sorry.
So Rust wants the enum variants to be uppercase.
Okay.
So let's do them sorry, with just one the title case, not uppercase. And then yeah,
What kind of type they should be?
you can put only open and close the curly brackets for now.
Okay, tuples. Okay. Check.
Or no, I think they need to be objects. So just put the curly brackets rather than the parentheses. And then inside here we can specify the arguments, but we can do that later.
Yeah. Peers.
I think it's peers,
Peers with this.
and that's it for now, right? Or do we have more?
No, we have this here. What is complaining about?
Command needs to implement debug and subcommand. So you need to do a derive.
Sub command, the one from clap, right?
Yes, and then there is one more thing we need to do, which is the clap rename. I'm gonna send it to you because it's a bit verbose.
Don't want to see me struggling with the keyboard for half an hour.
No, I don't want to see you suffer.
Are you sure?
Not for now.
Okay, so again, the rename must be put inside every.
No, you can put it at the top, just below the derive.
Okay, just on the
Perfect.
class, not it's not needed on each field.
Exact. And now we can specify which arguments do we expect there for every.
Okay, the code, to be honest, can take no takes a string always.
Exactly. So you can just say value column string inside.
Yeah, I was just checking. Sorry, in a second. Was taking yeah, always a string reference to string value. This is a reference to an str or
Just put a string uppercase, otherwise we'll probably need to deal with lifetimes. Don't think it's
mhm,
worth it. Then
info.
info is similar, but you can call it torrent or whatever, because then we get that reference to torrent file, right? And
I
peer
Yes, so
is also torrent file. Yeah,
yeah, I think so. Is the same because when we call the peers with the torrent file, info with the torrent file, and the code with a string. Yes, we can
exactly.
test.
So
We can test all of this later.
now it should be very easy. I think now the only thing we need to do is in our main, we need to call, so we need to do the parsing of the arguments and assign it to a variable. So basically replace this one, you can still call it args.
Mm,
Sorry, no, the one above, and do remove the semicolon as well. Sorry, the column, and do equal args with an uppercase A. So it's coming from clap args
yeah.
column parse. And then it's a function call, and that should give you our argument type. So at this point, you can do
Okay.
just a match saying match dot args, sorry, match args dot args dot. You should get dot command, I
We
think. Now, if you do args dot command,
we should have command in it. Okay, got it.
okay, and now you can match our own
Okay,
commands. So you can do command column decode, command column info. Exactly. And then you can
and
do the
well, we can call it encoded value, so we
It
can
needs to match the same name, I think.
okay, so we can go and
Unless you change there to encoded value, yeah, that will make sense.
just to keep the code changes to a minimum.
Yes, now you remember you need to do the little arrow thingy, the fat arrow.
The fat one, yes.
So maybe it's worth to do a super quick recap of what we did.
We created those three decode info and peers commands, and shake was added later on. We refactored our if else with a match that now is not matching and shake because I just added it and we still have to implement it.
Mhm.
Now, instead of having branches of an if with a string, we have a pattern matching with types using clap. And the code is the same as before. So here we can have some better handling of all of this. And now we are going on with the next stuff that we have to do. That going back to our here is to send this bunch of bytes to this
Mhm.
to appear of one of our list and get back the same string in theory or a slightly different one. That is the handshake. Here is the output. Okay, and then we have to output and print this to pass the tests. So,
Exactly.
and then we have to call it like this to test it. No, this is the old one. This tells that you have to call like this to get one of the peer to use here. That command is working because here we run it. Peers
Mhm.
sample BitTorrent. We have those three peers and we have to use one of these. My question when we stopped for technical reason was, does clap has anything to parse host and port, or we just parse a string and we split and then we use the 2 bits of the string?
Good question. With the, I think we can reuse the same struct we used to create an IP to parse it back. So we can probably do the splitting.
The peer structure here.
We had a struct. The peer struct
Before.
contains that IPv4 address. I think
Yes.
that one can parse an IP and give you the same
Mhm.
representation. So maybe we can implement a from string for this peer class.
Yeah.
Sorry, struct.
Can we do this in your maybe?
Maybe if it implements from string, yes. What does it say?
It say that should be clonable.
Okay, we can easily make it clonable, but I
Yeah.
think it will also need to implement from string. From
Okay, let's try to make it happy one step at a time. First of all, let's make it clonable. Where is it? I lost it. Clone.
okay, that was easy. Let's see if it's still
This was easy.
complaining.
Then
Probably
what
yes.
else? The method value parser for existing
What the
reference
hell is that?
auto value parser, but the straight bound were never satisfied.
Okay,
And
let's try to implement from
meant
str.
yeah, there is a from OS string. There is okay. Let's try from string.
Oh, maybe we need to do from OS3. Well, let's see what it does.
How it was to implement
No,
from
you need to
string.
say implement from with uppercase F, str. Sorry, all together, str with uppercase S, which should give you an autocomplete because that's the one. Okay, for peer. Okay, now it's complaining because you need to implement the methods,
Now he's complaining.
which should give you some auto generation if you click there on the error. Does Rust Analyzer a quick fix, implement missing members. So error, you can do whatever. You can do string if you want. Equal string, sorry.
Or equal nothing.
Or equal nothing, yeah.
Okay. Now, from a string, we need to split on semicolon, parse, and we hope that host can be, this one is parsing a string on its own, correct?
I think so.
So let parts equal to s dot split.
Yeah, I think that's what I was checking my code because I did this piece as well. Yeah, so what I did, I used split once, which makes things a little bit easier. And then you pass the delimiter, which can be just one char, so single quotes.
Yeah, I was fighting with it.
And then you can do.
Do we need to collect? No.
No, this will just give you a table with the two parts, so you can call it already, I don't know, row IP and row port.
Okay. But this must be unwrapped because it's an option.
Uh, Good point.
We unwrap or I mean, we should
You
error,
know what I did? I did the type of error as a string,
but we can,
because if you do the type of error as a string, then you can do before, rather than doing the unwrap, you can do OK or underscore or, and then inside you can do a string that says, I don't know, invalid format. And then you need to do dot to string because otherwise it's gonna ask you for a string, and then question mark at the end to get the raw value. So now if you hover on parts, you should see that you have a tuple with yeah,
to
reference to string. So you could destructure there. Like if you replace parts
mm,
with parentheses and
you
I
can
don't
have
know, IP
host,
import. Yeah,
host
something like that.
port, and now you can do host dot into and port dot. We have to parse it. We have to parse as IU16.
Yes, and both can fail. So I don't think you can do it like that unless you do again an OK or a map error or something like that.
Yeah, and also I need the curly brackets. I
Curly
jump too many.
brackets, and you need to give the field names as well.
I jumped too many languages recently.
I think it's a column, not an equal.
Like I said, I jumped too many languages.
Okay, and
Now,
now that one can give you an error, like can give you a result type. So you can do a dot map error. Why it doesn't give? Oh, because I think into doesn't work like that. Into works only if it cannot fail. So you can try to do from. Sorry, you can try to do IPv4 address, the type. So delete all of that and do IPv4
my God, my keyboard address.
from str. I think there is somewhere,
I don't see from str.
and then give your own IP or host, yeah, and then you can do dot map error,
Okay, now it has a map error.
and this needs to return a string. So you can say whatever you want, like invalid IP or something like that,
Yeah, the same as before. Invalid peer host.
and also need to add the question mark at the end because you
Yeah,
want to unwrap.
propagated error. Is happy now?
Yes, but it doesn't like the next one, I think.
Okay, the parse one.
Now this is correct. We just need to map error, I think.
Okay, U16 instead is a result. Let me take this invalid peer port.
Perfect.
And
Now why
now
is still complaining?
not happy because we need to give back a result. So
Oh
this is
yeah,
an
just wrap
okay.
it in an okay. Yeah.
This is an okay. And
Okay. Why doesn't like that? Oh, because these are closures, so you need to put the pipes.
Why I'm not doing the okay.
And I think no, you can just leave the pipe, but probably wants an argument. So just put an underscore between the pipes. Okay, and the same you can copy in the other one.
Everything is happy.
Everything seems happy. So now is clap happy as well.
Okay, back to us. Clappy up there, here.
Nice. Seems to be parsing it.
It's
I don't know.
telling nothing. Let's go down here and make this switch case, sorry, this match case happy. Okay, we are here. So it's a command and shake that takes, let's change the brackets, that gives us a torrent info and no, not happy. I have to, ah no, it wanted the curly ones. That are another couple of them. And now
Mhm.
what is
This will be appear.
unused? Okay.
Perfect.
So now, what we have to send and how we have to send? We have to send the SHA info that we have to compute. At this point, we should extract the the function that computes it. The hash value is here. This hash value is a string. What we give back, the string as binary or the string as we give back the string as but those are the pieces. No, we don't need the pieces. We need what SHA do we have to send again?
Or do we get it from the CLI? No, right?
No, we get the file from the CLI. We have to send this hash. Yeah, we have the compute hash binary. Okay. So let's copy this, but this should become a function. Let's make this a function. What do you think?
Yeah, let's do that.
So it takes a torrent file and give you the info hash. Function compute info hash. It takes. Let's give directly the file name. Yeah, why not? Give directly what is this file? Is a string. Yeah.
Okay.
So we do stuff like this. We take a torrent file as a string and we give back what do we give back? What is this guy? We have to give back this.
It's just a vec of U8 or what?
Well, depends what we did this function. This function gives back a vector of U8, yes. So okay, request was not used here. We just took it. IOS URL is not needed here. So it's just the coded info like this. Okay, back to us. We will replace the code later.
Mm-hmm.
Here, first step is let info hash equal to compute info hash for our torrent file, and we have our info hash. Now, Tokyo to connect it to the peer and start sending out bytes.
Can you just do a print first of the, I guess, the info hash and the peer? So at least we know everything else is working so far.
I do a DBG,
Yeah, that
no,
works as
BG, a
well.
BDG, BDG of peer and if no, because info hash is binary, so if I print it, I don't know what is coming out of it. Mm.
Yes, you're right. But should print like a list of U8.
And shake, if I wrote it correctly, and we take this one. Do you like
Hmm.
it?
Yes.
And it exploded.
Command. What doesn't have this field? Oh, did we use a different name in the destructuring?
Okay, what do we use? Ah, yes, we call it peer.
I'm surprised it didn't complain there, but anyway. Cool. Okay, so this is
Yeah,
working. It was able
fast
to
port.
decode.
Yeah, and our 20 bytes. Yeah, it didn't complain there for some reason. But who knows? Now we know that
Okay,
we have the right stuff. We need to create this message.
so there is a struct that I'm gonna put here in the chat and send it to you as well. That I don't know if you can open it in the browser. We can have a look at that. There should be some examples.
Okay, let me make the font bigger. What we have here?
So you can do like a connect, as you can see at the beginning, or
Mhm.
almost every example, and I think that gives you a channel where you can do read and write, basically.
Okay, so we write the single information that we have to send out. We don't prepare the message and we send it out all together.
I guess we can decide, but at the end of the day, the low level interface is you need to write bytes into this object.
Yeah, it's when they get flushed. My concern.
Oh, good question. I think maybe we need to explicitly call flash because this is like a stream. This object should work
Yeah,
like a.
set keep alive. There is a flash. Complete. I don't see a flash. So it's flashing on.
Yeah, let me see the way I did it, which is not necessarily the best way, but at least I was able to pass this part of the challenge.
But well, anyway, let's copy this and connect. We parsed um, a peer. So we have a port and an IPv4. Do we need them? Because I see that this connect. What is this connect taking? We need the Tokyo net, right? Yeah,
Mm-hmm.
Tokyo net. Oh, and the main is not throwing an error. We need to make it throw a result or an error to use the question mark.
Okay, I think what I used, there is a function called write all that makes sure when you do a wait that writes everything and is flushed. So we can probably use that on the stream
Write all.
underscore all. Yeah.
Okay, but we need to prepare this buffer then.
Yeah, we need to prepare the sequence of bytes as per the specification.
Okay, so let's make now giving back this error. What kind of error it is?
I think that's a generic error, yeah.
Is this going to conflict with any that we have already or not? Okay, we will find it out. Now, all of these should return some bunch of OKs to make it happy.
Yes.
Okay, and here I can leave what to do for now. So now let's connect to the peer. Can I don't think we can use a peer directly, but what it takes an address of type A. Can A be
Yeah,
what can
what
A
is
be?
good question.
Connect an address of type A. Thank you. And A should be what? Here they always use strings, but we have parsed the string.
I think if you pass a tuple where the first one is an IP and the second one is a port, that should work.
Okay, so let's do
But
as
I'm sure that there is some kind of trait that we could implement in our peer to.
well, at the moment I implement the function as tuple and I return it. No,
Mhm. Oh yeah, that's perfect. That makes sense.
self was like this. No, was like this.
Yeah, that's correct.
I return a tuple of a EP before and a U16. And what I do is just giving back self.host and self.port. It will complain about copying. No, because we implemented clone, so he's not complaining.
Hmm.
Okay, he's complaining down here the connect at this point. Connect is happy. Connect seems happy.
Anyway, if you really want to, we just need to
Right.
implement this trait,
Talk you to socket address.
and then we return the tuple that you just created.
Okay, so let me go back to my implementation. Here,
So you need,
implement
yeah, you need
this
to do another, yeah,
for,
for, and then what is the method that it wants?
let me remove this for peer. Okay, look.
Yes, I'm trying to see if there is an example. Does it tell you? Did it give you an auto
No,
implementation?
that doesn't give me an auto implementation. What should I implement?
Interesting. Yeah, I don't understand this code. They use something called sealed, which I've never seen before. I can give you this example if you're curious.
Okay, this is getting complicated.
I'd say let's stick with the table, but yeah, if you're curious, you can open that link.
Okay, here you implement to socket address. Okay, you implement sealed to socket address for the address. Here you implement with TP address and the U16.
Yeah, I think the complexity here is that because you might want to resolve, for instance, like a DNS,
Yeah.
they use this future to do something async. So I would say let's just stick with the table.
Okay, let's go back to our. Oh no, I closed one tab too much. Let's go back to the previous implementation of control Z, control undo, undo, undo. Let's go back here. So
Hmm.
this is readable. The other stuff is fancy, but it's not very readable, if you ask
Exactly.
me.
I mean, it would be somewhere else, but yeah.
So now we have to stream, and now we have to write all, and we have to write all something. Okay, this is something we can prepare what it takes. An array of bar of U8 is good.
So you can use a vacuum of U8.
Well, no, we know exactly the size, so we can use an array.
Oh, that's true, but then the array you need to, well, you can initialize to zeros, yeah, which is the default, I think.
Yeah, but how big we need it? Let's go back to our with this 1 byte, 19 is 20, 28, 48, 68. And it's not bugger, but it's buffer.
I was wondering if for you bugger meant something.
No, is the F and G are near on the keyboard. I don't know if we need a response buffer, but it will be the same size. Now we have to populate all of this buffer stuff.
Mm-hmm.
So the first one is like they say 19. Then a easy way to copy an str into an array of U8 starting from an index.
Good question. I wonder if you do buffer and then square brackets and you put the indices beginning and end with the dot dot, I think, yeah.
This is in theory between that and that, and it is copy this so that I don't want to get it wrong.
And you probably need to put a B in front of the string to say as a binary thingy. Let's see if that works. I'm curious.
Okay, this is complaining that.
What?
Found a reference to 19 bytes. Okay, and in this side, the size of the value U8 cannot be. I don't think it works. But well, can we cycle through this buffer 1 byte at a time and copying it?
I think so, yeah, but there must be a way. Let me see how I did it.
But maybe you didn't use an array, you used a vector concatenating to the vector, but
Can you write into the buffer?
why not? It's immutable and is not complaining about this line.
Can you, if you do buffer dot, does it give you like a write?
You mean buffer dot concat join a line as mutable pointer as a slice binary search clone fill get is last chunk is writer copy within
Copy within, maybe. Interesting.
swap with slice. What is copy within? Copy element from one part of the slice to another part of itself. No, is
No.
inside the slice itself.
Yeah, I took the easy path and I just did a vec and then pushed stuff
Okay,
into it.
let's do a vec. We do a vec of U8.
And you can do equal vec with capacity. If you do vec uppercase V,
Okay. Vec with the capacity, and it was 68.
yeah, so I shouldn't resize it on the heap.
Okay. Buffer dot push
Push.
19. Then we do our buffer dot append
You
to add
can
multiple
do
values.
extend from slice, I think.
Okay. Buffer extend from slice. Ingrim is called Ingrim append is doing append concatenation
Mm.
of vectors. Okay, then what we need to do, 8 by reserved, they are always 0.
Well, now you can do extend from slice. Can you do that?
Mm?
Because not 8-bit, right? It's 8 times 0.
It's 8 times 0, yes.
Oh, yeah, you can do that. Fair enough.
I don't remember if this is the right way of escaping in Rust, because like I said,
Seems happy.
I use too many languages. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Your info hash. Okay, my info hash is already what is the type? It's a vector of U8.
By the way, just for fun, an alternative could have been to just have done this, the ampersand square bracket 0 semicolon 8. I think that would have been the same.
Okay, the ampersand, you say
Square
square
bracket.
bracket 0, 8 square
Yeah.
bracket. Here we extend with info hash. Info vector is already as a slice.
Hmm.
And then the last one is the peer ID, 20 byte, our peer ID. Okay.
Which we have created somewhere at the top, right?
Yeah, we have a constant called peer ID, but it's a string, so we have to do s bytes is enough
I think so.
because it's a peer, it's
Hmm.
a reference to an str, so no UTF-8 in it. Now we have our stream that is complaining that stream cannot borrow stream as mutable as it
Oh, and you
because
need to
of,
declare it as mutable.
must be mutable. Okay.
Now
Nice
this
complaining.
needs to be awaited because it's async.
Okay. Nothing, dot await, so dot await. Now it should throw an exception. And now it's finally happy. Now we have to read also. Okay, after we send an handshake, we should receive an handshake back in the same format. Your program should print the hexadecimal representation of the peer ID you have received during the handshake. So now we have to receive.
Hmm.
The peer ID will be the last 20 bytes, and we have to print the X version of the last 20 bytes of what we receive. Now, how do we receive with Tokyo?
Yeah,
Let's go
let's
back
see
to the
what's the best way.
documentation.
Okay, what I use is read underscore exact,
Okay.
where what can you do?
Where do you have read underscore exact?
So on the stream itself, did you call it stream? The
Yes. No, I was looking if there was any documentation.
So you need to prepare a buffer, an empty buffer of a specific size, and then pass it to read exact. But I don't remember. I should be there somewhere.
Okay, but well, if you tell me that it is there, I trust you. I already have the buffer here because I was preparing it before.
Oh yeah, we can reuse the same one. Why not?
No, I have another one. That's not overwrite it. So stream
But
dot
technically, you could, right? It's just you want to do it just to be clean, but technically
yes.
you could reuse the same memory,
Technically,
right?
you could reuse the same memory. Yes. And it wants a reference to a mutable buffer. So is already mutable, but is not a reference. One day I will understand all of this. Not today. And this must be awaited again. No?
Yes.
Doesn't trigger. No. An array is not a good buffer.
That's interesting.
So what did you use?
What did I use? Did I use a vec? Yeah, I used a vec. I'm not sure. I thought an array would work.
Here in this example, the read buffer is using a bytes mute with capacity.
But I think that's an external crate that bytes colon bytes mute.
Yeah.
Yeah, I don't know why they use that one, but a vec works as well.
So again, let's make a vec of U8 with capacity.
Yes.
Okay. At this point, is complaining that that is not awaited. At this point, I can await. I can put a question mark. I want to understand why it's changing the layout of the keyboard in the middle of writing. And at this point, we have to print
Yeah, a specific range of bytes, right?
Yeah, a specific range of bytes.
The problem is
Mm,
that we will need to read that as a string, right? Or not? As
let
a,
me try something. I have to go back to that exercise because I need to copy this just to satisfy it completely. And here we have our response buffer. The last, I want the last 20 bytes. So it is between 48 and 68. How do you slice a vector? Like it was an array,
48 dot dot 68
68, and there should be x, what we used to convert it to x before.
as X string or something like that.
It was encode x string, so it was this that runs on top of, this is a generic array.
Whatever that is, yes. Hopefully that works as well for a generic slice. No.
Eh,
Oh, maybe once a reference in front of the response buffer, an
the
ampersand.
size of the value you wait cannot be, no,
Use
configuration.
an ampersand before response buffer. Do you need to put parentheses? Hmm. Try to put parentheses before the ampersand.
Sorry, where?
Keep the ampersand inside the parentheses.
Inside the parentheses, like this.
Mm-hmm. Is that happy?
Okay.
Seems to be happy.
Okay, so putting the parentheses, we told to take a reference to these 20 bytes, encode them and as a string, and now print them. Now, if we do the handshake, what is going to happen? It
Wow,
did something.
it didn't explode.
It didn't explode. Nice. So now on CodeCrafter, we run test,
Turbo tests.
turbo test. Not so turbo today. Compiling, compiling. We need some kind of music for waiting.
Exactly.
Is running test. They pass. They are passing. Everything passed.
Nice.
Yay!
Look at that. The name is Strawberry, the name of the peer.
Now this is a
Oh
decode.
no, this is the test of the day. So it's
Yeah,
always running
because
all the tests.
yeah, it's running. The peers are here. No, here they are the peers. The handshake is here.
Okay, it's
Handshake.
always an hexadecimal. Okay, yeah, fair enough.
Okay. The yeah, because it's decoded. Eh, it tried locally, so it knows the peer ID because it's connecting locally.
Hmm.
Those are the tests. So, and also is using running all the old tests for the old steps to see if we broke something. This was just a decode.
Yes.
Okay,
Yes.
back to us. We can finally CodeCrafter submit. Running the test again on submission. Maybe,
Could be.
maybe,
Yeah, I
maybe.
think if you do from the web, it will just be
It's
faster. I
going
don't know.
to be faster. Don't know. Test running tests.
Okay, so it needs to run the tests again for whatever reason.
Yeah.
Okay, I'm curious to see what's the next challenge.
We'll go there as soon as it's compiling.
Hmm.
It's compiling. As soon as we have it. It's bothering me a little bit that we had to use a vector instead of using an array. Because, I mean, the C programmer in me wanted an array.
I'm sure that there is a way to do that.
Okay, so passed. Mark this stage as complete. View the next stage. So let's go and read what is the next stage. Then we can call it a day. Luciano, what do you
I
think?
think so, yeah.
Okay, in the next stage, you will download one piece and save it to the disk. In the next stage, you will combine the pieces into a file. This is classified as art. Ooh, we didn't look what was classified and shake, but well, sorry, I'm curious. Medium. This should take how long in their mind? 30 minutes to 1 hour to complete this stage. Well, we stayed in 1 hour.
Okay,
Don't
we
mind.
also did some extra refactoring, so
Yeah, we did extra refactoring. We chatted a lot, and we had some technical issues. In this stage, you will download and put stuff together. To download a piece, your program will send a peer message to a peer. The overall flow looks like this. Read the file torrent and get the URL. You done this previously. Get the tracker, the list of peers. You did
mhm.
this previously. Establish a peer TCP connection with the peer and perform an handshake. You have done this
Okay, all of this
previously.
is done.
Exchange multiple peer messages to download the file. This is the part you will implement in this stage. The peer message consists of a length of a prefix for bytes, a message ID, and a payload variable size.
Sorry, Roberto, we have W Gaffa on the chat saying, what is it saying? Hey, how much have you done on the torrent client? Okay, this
Do
was
the
like
length.
8 minutes ago, so apologies, I'm seeing it only now.
Okay.
But yeah, you can probably see that we got as far as implementing the handshake
And shake.
protocol, and now we are starting to look how to do the downloads.
Here are the peer messages that you need to exchange once the handshake is complete. Wait for a bit field message from the peer indicating which pieces it has. The message ID of this message type is 5. You can read and ignore in the payload for now. The tracker we use for this challenge ensures that all peers have all the pieces. Okay. Send an interested message. The message ID for interested is 2. The payload for this message is empty. Wait until you receive an unchoke message back. The message ID for unchoke is 1. So here probably we have to do the numeration with all 1, 2, 3,
Hmm.
and so on, mapping to these enumeration possible values, right? Break the pieces into blocks of 16K and send the request message for each block. The message for request is 6. The message ID is 6. The payload of this consists of index, the zero-based index of the piece, begin, the zero-based byte offset of the piece. This will be 0 for the first block, 2 at 14 for the second block, 2 at 2 multiplied 2 at power of 14 for the third block, etc. Why we should send the piece index and also the offset? Well, who knows? Length, the length
Because I
of
think
the
you
block
can
is
download part of a piece. I don't think you need to download it entirely.
okay. Anyway, the length of the block in bytes. This will be 16K. It was, yeah, 16K. The last block will contain 16K or less. You will need to calculate this value using the piece length. Okay, so we have to compute the
Mm.
leftovers when we ask the last one. Wait for a piece message from each block you have requested. The message for piece is 7. The payload is whatever. After receiving blocks and combining them into a piece, you will want to check the integrity of each piece that by comparing its hash with the piece hash value found in the torrent file that we
Makes
computed before.
sense. Yeah.
Here is how to test. The tester will execute the program. So your torrent download piece dash o, the file where to write, the sample torrent file, and the index of the piece that we want to get. Okay, good. Nice. Is a lot of calls. What I don't get
I
from maybe we should look at the protocol.
yeah, I didn't understand why a bit field. What do they mean by that? Is it just a sequence of bytes or is some special data structure there?
A bit field normally is an integer with as many bits as needed to represent 0 if you don't have the part, 1 if you have the part. And
Mhm.
normally they use variable integers. They can be encoded with different encodings.
Oh, I
That
see. Okay. So if you have 20 parts, it will be a number of 20 bits.
bit, but
And then,
that
yeah.
number of 20 bit is going to be encoded in a multiple length integers. There are multiple techniques to do that. For example, there's a technique that the number is always the eighth bit is always one, except in the
Mhm.
last integers that is always that is 0, that tells you that is terminated. So basically you have 7-bit numbers. You have to concatenate in little endian 7-bit numbers, and that is the final bit payload. But in this case, we have to ignore it. Now, what I didn't get is that can we send a request for everything and in another thread listen for the responses?
Mm, good
I
question.
mean, I want all the pieces of this part. I send all the requests together, and at some point they will come back with index 7 that tells me that this is a message I
But
need
you
to.
are always reading from the reading and writing the same stream. So I suppose that to do that, you need to establish multiple connections, do multiple handshakes, and then.
Uh, well, you can write one message after the other, and reading can happen in parallel from write. In
Can
a
it?
socket, normally you can read while you can write. They are not the two operations are not blocking each other.
Yes,
But
but then you are still reading sequentially. That's what I mean.
because the server will send you the parts in random order at that point.
And sequentially, not in parallel, right?
Sequentially in random order, but still maybe you optimize the code because you send, you get, you write to disk. You send, you get, you write to disk. This way you send, 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 send. In the meantime,
Mhm.
receive, receive, receive. Write to disk, write to disk, write to disk.
Yes, you can probably optimize a little bit, yeah. Also,
But
the write to disk, that's something I was wondering. How can I suppose there is some operative system call that you can do, but you'll need to write, like you need to seek the file and then write in a
it's
specific
called
place, right?
exactly seek. Yeah, yeah. You can call seek.
But does that mean that you need to pre-allocate the file of the final size with all
Yes,
the 0
you
bytes
can.
or
You
whatever?
open the file and you write. The size bytes,
Mhm.
and then you seek and write inside the file itself.
Okay.
If
And
we
then
don't need
when you
the
need to
sequence,
compute the hashes, you know exactly which bytes are you interested in and which hash should it match.
the
So
hashes
yeah.
should match the whole packet that we are downloading, the whole piece that we download.
So you will buffer all of that piece in memory, check the hash,
We can
and then
directly
write
write.
to.
We can choose. We can buffer in memory depending on the size, or we can buffer on disk. You write to the disk. When you are done, you read back from the disk. You compute the hash and you check if it's correct. If it's
Mhm.
not correct, you try again.
Okay, I'm just wondering if it makes sense in Rust to do a mem map, but maybe not.
Maybe yes.
I have
Why
no
not?
idea if there is a safe way to do that, but could be interesting to check. But probably
We
for
can,
next time.
we can write to memory everything and then flash the memory to disk at the very end when the hash is correct. Uh, these imply that the pieces are not 20 gigabyte, but I don't think they are.
Hmm.
So I think it's fine. Okay, so this is what we need to do next time.
Okie dokie. So, should we wrap it up?
I think so.
Okay, so gonna go back to the chatting screen. Thank you everyone for joining today. I hope this was interesting. If you are following from YouTube, you know we stream on Twitch more or less every Monday. We haven't been the most consistent lately, but we'll try. So hopefully follow us on Twitch. You'll find the link in the show notes. And if you are following right now on Twitch, we have all the recording on YouTube, and the link is available in the chat and also in our profile. So next time we're going to continue with this exercise. We also have a repo with our solutions. Actually, we have two repos because we today we in the streams we are working on Roberto's solution, but I'm also trying to do it in parallel, and I think we came up with slightly different solutions sometimes.
Yeah,
So we link both repos if you're curious. And I think that's all we have. Let's see if we're gonna do a raid. Okay, so we are gonna do a raid to someone in English, I guess.
not in Portuguese. No Portuguese for us today.
Exactly. Yeah, nobody's doing Rust, so it will be something around game making with Godot. So hopefully
It's
you will
not
have
Rust
fun.
Day.
Not Rust Day.
Not Rust Day.
All right, everyone. Have a good day. Bye.
Bye.